only those three operations. However, applying those three operations has to be done in a particular order. If I mess up the order, I will not solve the system. And the order has to be this. This is the first thing I need to accomplish. I need a 1. Well, it's already there. I have a 1 in the upper left corner. First row, first column. So that is done. The next step is I want zeros here. I want this to be 0, and I want this to become 0. I will definitely have to, I cannot write the equal symbol between these matrices. It has to be an arrow. No equal symbol between this matrix and the next one. I will have to multiply the first row by -1 and add it to row 2 to get a 0 here. I will have to multiply the first row by -1 and add it to the third row as well. The first example will take a little while, as you know. It's going to be clear, but we need to practice this. Okay. I copy the first row. 1, 2, -1, -1. I always copy the row that I'm using. So now, together with me, please. 1 multiplied by -1 plus 1.
2.
One more time. 1 times negative.
Okay.
Right.
1.
Okay, one more time. 1 times -1. -1 plus 1.
0.
That's what I said. We want a 0 here. Okay, next.
Where you get +1 from?
I'm sorry?
Where does the +1 come from?
1 multiplied by -1.
Right.
And now I have to add row 2. Plus 1. 0. 2 multiplied by -1.
-2.
Minus 1.
-3.
-1 times -1
1.
plus 1.
2.
-1 times -1
1.
plus 4.
5.
That's it. We accomplished this operation. One times -1 plus 1. 2 times -1
-2.
plus 1.
-1.
Very good. -1 times -1
1.
minus 3.
-2.
Very good. Last one. -1 times -1
1.
minus 2. Very good. So what have we accomplished? And this is very important to remember. I have to get the 1 of the column first. Once I have the 1 of the column, then I will get the corresponding zeros of the column. Now, what do you think I am going to do here? What is my next step? I need to accomplish the 1 of this column. Where will that 1 be? Right here in the middle. Right here in the middle. I have 2 options. I can divide this row by -3 to get the 1. I don't want to. Because if I do that, this would become -2/3, and this would become -5/3. But look what I can do. I'm allowed to swap. Why would I swap? Because I have a -1. And a -1 I can easily get it turned into a 1. How would I get a 1 instead of a -1? What do I have to do to both sides of this? That's it. So I'm going to swap. I'm going to say row 2 becomes row 3. Arrow, not the equal symbol. Copy 1, 2, negative 1, negative 1. 0, negative 1, negative 2, negative 1, and 0, negative 3, 2, 5. All we did was we replaced 2 with 3 and 3 with 2. I need now to get a 1 in here. I can only use one of those 3 operations. So what should I do to get a 1 in here, not a negative 1? One more time.
Multiply by negative 1.
So R2 gets multiplied by negative 1. Arrow again. I copy 1, 2, negative 1, negative 1. I copy 0, negative 3, 2, 5, because those do not change. And what do I have in the very middle now? I have 0. I have
1.
I have. So what have I accomplished? I have all this done, and no one can ever change it, and it will never be changed back into anything else. I have accomplished the 1 of the column. Now I need a 0 here instead of a 2, and I need a 0 here instead of a negative 3. I will have to use which row? Which row will I be using for accomplishing the 0 here and the 0 here? It has to be, exactly, it has to be row 2. So row 2 will be multiplied by what and added to row 1? Row 2 will be multiplied by what and added to row 3? What will you tell me to multiply row 2 by? I'm sorry? We wrote that last time. We can never multiply anything by a 0 number. Ever, ever, ever. Yes, with negative 2, I completely agree. And what about for this one? Very good, very good. So now let's do this together, please. Arrow, not equal symbol. I have to copy the middle row now, because that will not change. I have to copy the 1 and 0, 0. That will not change. Ready? 1 times negative 2 plus 2.
0.
2 times negative 2
Negative 4.
minus 1.
Negative 5.
1 times negative 2
Negative 2.
minus 1.
Negative 3.
1 times 3
3.
minus 3.
0.
2 times 3
6.
plus 2.
8.
1 times 3
3.
plus 5.
8.
What did we accomplish? A lot. All this is done. Where is my next target? Mandatory step. I cannot mess with that. Say it again.
Front arrow. 7.
No.
8 needs to be on
Exactly. I want this 8 to be a 1. How do I make this 8 to be a 1? Divide row 3 by 8. Awesome. One zero 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 1 0, negative 5 and negative 3 2 1 1 1. I divided both sides of row 3 by 8. Can anyone tell us how much is Z right now? and nobody will change that. Final step. I need to get a 0 here, and I need to get a 0 here. I will be multiplying which row now? I need the 1. Without the 1, I cannot get the zeros. Without the 1, I cannot get the zeros. Without the 1, I cannot get the zeros. So which row will I use? Exactly. R3 times something plus R1, R3 times something plus R2. What will I multiply row 3 by to eliminate the -5? Very good. What will I multiply row 3 by to eliminate the +2? That will be the final step. 1, 0, 0, 0, 1, 0, 1, 1. Ready? 1 times 5 minus 5. 1 times 5 minus 3. Very good. 1 times -2 plus 2. 1 times -2 plus 1. That's it. Can anyone now, you do not trust anything, I don't trust anything, this is not for sure, we have to go back and check. But assuming we did not make a mistake, what is the solution of the system? 2, -1, 1. It comes with a big question mark. I have to go back to the original system, plug it in like we always do, and check. So I'm copying the system. The system was x plus 2y minus z equals -1. It was x minus y plus z equals 4. And it was x plus y minus 3z equals -2. So our claim is 2, -1, 1. 2, -1, 1. 2, -1, 1. 2, -1, 1. Ready? 2 minus 2 is 0. -1 equals -1. True. 2 plus 1 is 3 plus 1 is 4. True. 2 minus 1 is 1. 1 minus 3 is -2. Yes. And only now I'll say yes. And I determine the solution using matrices. I did not tell you what method this is. Now I'm ready to tell you. It's called Gauss-Jordan method. Let's choose another problem and work on it. Slowly, step by step. The second one should take much less. The third one should be a breeze. Okay, we are on page.
How does that second one work out? I don't
Say it again.
2 minus 1 plus 1 is 3.
Which one are we, which equation?
The middle one.
-1 times -1 is +1. 2 +1 is 3. 3 plus 1 is 4. That's okay. That's okay. It wasn't clear because it was too crowded in there. Okay, so this was problem, I think, 29. Let's do, I don't have any preference. Let's say 22. X minus 2y minus z equals 2. 2x minus y plus z equals 4. -x plus y minus 2z equals -4. Can anyone dictate the first step? So the question here is the same. Use Gauss-Jordan method to solve the system. Yes, I have to do, yes. And since I'm not really doing much with it, it was just a preliminary, I'm going to go directly to the augmented one. Just make sure that all the system is in the correct order. X below X, Y below Y, Z below Z, correct? Okay, so the augmented matrix, anyone can dictate?
1,
Yes,
negative 2. Oh, 1,
it doesn't matter, just tell me you're going by rows or by columns. Okay,
negative 2, negative 1, 2, 2, negative 1, 1, 1, negative 1, 1, negative 2, negative 1.
perfect. Where is my starting point? Mandatory starting point. Exactly, and that is already accomplished. It's the 1 of the first column. Without the 1, I cannot create the zeros. So now I will have to create the 0 here, and I will have to create the 0 here. Obviously, which row will I have to use? Mandatory. Yes. So will be row 1 multiplied by something plus row 2, and row 1 multiplied by something plus row 3. Let's analyze what we need to multiply row 1 by to eliminate the 2.
Negative 2.
Negative 2 indeed. We agree with negative 2? Good. So now what do I have to multiply row 1 by to eliminate the negative 1? Indeed. Very good. I draw an arrow, not the equal symbol. Which of these 3 rows will not change right now because I'm using it to do something with it?
Row 1.
Very good. Let's copy row 1. 1, negative 2, negative 1, 2. Careful how we start. 1 multiplied by negative 2 plus 2. Negative 2 times negative 2 minus 1. Negative 1 times negative 2 plus 1. 2 times negative 2.
4.
Negative 4 plus 4.
0.
Very good. 1 times 1 minus 1. Negative 2 times 1 plus 1. Negative 1 times 1 minus 2. And 2 times 1
2.
minus 4.
Negative 2.
What did we accomplish? The first column is done. Where is my next target? I cannot mess that up. If I go somewhere else, I will never solve.
Column.
So I need here what?
1.
I need a positive 1 in that particular spot. I cannot continue till I get a 1 in that particular spot. What is the easiest way of getting a 1 in that particular spot? Dividing row, which one? Which row? Row 2 by? That's it. Very good. Awesome. One zero zero. 1 1 0. Negative 2, negative 1, negative 1, negative 3, 2, and negative 2. I divided row 2 by 3. What have we accomplished so far? We have accomplished all this column, which no one can go back and touch. And we have accomplished the 1 in the middle column, where it should be. Which row will I make use of now, because I need a 0 here and a 0 here? Very good. So I'm multiplying row 2 by something and adding it to row 1. And I'm multiplying row 2 by something else and adding it to row 3. Perfect. What do I multiply row 1 by to eliminate this negative 2 at the top? by 2. What do I multiply row 2 by to eliminate this negative? Perfect. Arrow, not the equal symbol. 1, 0, 0, 1. 1 and 0. With me, please. 1 times 2 minus 2. 1 times 2 minus 1. 0 times 2 plus 2. Very good, awesome. 1 times 1 minus 1. 1 times 1 minus 3. 0 times 1 minus 2. What have we accomplished? A lot. Where is my next step? Otherwise, if I don't go exactly there, I mess up the problem I can't solve. Exactly, row 3. So then, row 3 needs to be divided both sides by? So, 1, 0, 0, 0, 1, 0, 1, 1, 1, 2, 0, 1. I am making use of which row now because I need to get a 0 here and a 0 here. Obviously, row 3 needs to be multiplied by something and added to row 1, and row 3 by something and added to row 2. Very good, in both cases, awesome. So, 1 times negative 1 plus 1. So 1 times negative 1 plus 1. 1 times negative 1 plus 2.
2.
1. 0. I'm sorry, negative 1 times negative 1 plus 1. 0. 1 times negative 1. Negative 1 plus 0, negative 1. Assuming we have not made any mistakes, which we will not assume, we will go back and check, what could be the solution? Do you all agree?
Yeah.
Because everything disappeared here, just an X and a Y and a Z. Because we got all these zeros. We made it happen. But please remember the sequence of steps. First, I have to obtain the 1, and then using this, get the zeros. Then I get the 1, and using this, get the zeros. Then I get the 1, and using it, get the zeros. That's the only way. Okay, so where is our system? Here it is. So 1, negative 1, 1. 1, negative 1, 1. 1, negative 1, 1. 1, negative 1, 1. If it happens that you work so hard, which is not very easy because it's a lot, we have a lot of steps, and at the end you check and it doesn't work, don't try to find a mistake. Start from scratch because it's really hard to find a mistake. Okay, so let's check. 1, and this is 2. 1 plus 2 is 3. 3 minus 1, 2. 2 plus 1, 3. 3 plus 1, 4. Negative 1 minus 1 is negative 2 minus 2 minus 4. And now I can say yes. Okay? It's not a difficult method once we understand it, but it needs a lot of practice, however. Do we need another example or we move on?
We do one with more rows. So there's just a couple of examples.
No, just 3 is enough.
No, you just read that. Oh, we got some examples.
Say it again?
I there's some problems in the problem section that I had.
With 4?
Yeah.
Okay, let's do one with 4 then. I will not put it on a final exam or test. One with 4. I'm not testing endurance, I'm testing method. No, but we, since you mentioned that there is something in,
It's 4 rows,
yes, let's do it. What is it?
18, it's 1, -5, 2.
On rows or on columns?
On rows. 1, -5, 2, -2, 4. 0, 1, -3, -1, 0. 3, 0, 2, -1, 6. -4, 1, 4, 2, -3. And then off to the side, it says -3 R1 plus R3, and then a second.
So it tells you what to do. We don't need that.
Oh, is that what it's doing? Okay.
They can keep that to themselves.
Okay.
We don't need their
Is that what that is? Okay, that's just.
this is what we,
solution stuff.
yeah, this is what we did.
Okay.
Yep.
Yeah, so I see that.
Very good. Okay. So the starting point is here. I have accomplished the 1, and now I need a 0 here, I need a 0 here, and I need a 0 here. There's nothing I need to do for this one because 0 is already there. So I need to accomplish a 0 here and a 0 here. So please tell me what to write. Which row am I using?
1.
So R1 multiplied by something and add it to R3, and R1 multiplied by something else and add it to R4.
-3 and 4.
Very good. Awesome. Which row do I have to copy, or in this case, which rows I copy untouched? First and second. Very good. Ready? 1 times -3 plus 3.
0.
-5 times -3 plus 0. 2 times -3 plus 2. -2 times -3 minus 1. 4 times -3, -12 plus 6. 1 times 4 minus 4. -5 times 4 plus 1. 2 times 4 plus 4. -2 times 4 plus 2. 4 times 4 minus 3. This is accomplished. This is accomplished. That's my next step. So now I have to work hard to get the zeros here. Yes, I have to multiply row 2 by and add it to row 1. I have to multiply row 2 by and add it to row 3. I have to multiply row 2 by and add it to row 4. Five indeed. Indeed. Very good. Awesome. Any questions? I have to copy 1, 0, 0, 0, and I have to copy 1, -3, -1, 0. These are the only column and row that will not change right now. Good. Ready? 1 times 5 minus 5.
0.
-3 times 5 plus 2. -1 times 5 minus 2. So 5 times 0, 0 plus 4, 4. Now the numbers are getting weird. Okay, 1 times negative 15 plus 15. Negative 3 times negative 15 is 45. 45 minus 4, 41. Where am I? I'm here. Positive 15. Yes, positive 15 plus 5, 20. And 0 minus 6. Last one. 1 times 19 minus 19. Negative 3 times 19, it's negative 57. Is it? Negative 57 plus 12. Negative 45. I'm here. Negative 19 minus 6. And 13. What did we accomplish? Where is my next step? So, yes, I need here a 1. But look at all this tragedy here. Because I have to divide by 41.
You can swap it.
Even if I swap it, I have to divide by 45. And dividing by 45 is, or 41 is not a problem. The problem is that I would have to multiply fractions to get rid of the rest. We were asked in this problem to use Gaussian elimination or Gauss-Jordan. Because I think they are probably asking for Gaussian elimination.
Doesn't say.
It doesn't say. Okay then, it doesn't matter then. Okay. So you kept up with the numbers, right? The numbers are correct? Okay, because that will be a big tragedy. Okay, so 1, 0, negative 13, negative 7, 4, 0, 0, 0, 1, negative 3, negative 1, 0, 0, 0. So I'm going to divide R3 by 41. 1, 20 over 41, negative 6 over 41, negative 45, negative 25, and 13. So what did we accomplish? I have the 1, and now I have to destroy these, change them into zeros. So I have to multiply row 3 by something and add it to row 1, row 3 by something else and add it to row 2, and add it to row 4. Yes? Yes, 13 indeed, 3 indeed, and 45 indeed.
What happens if we put equal?
What happens if it?
If we put equal instead of the arrow?
They are not equal. You can't put equal. They're not equal. They are equivalent, but they're not equal. Okay, good. So 1, 0, 0, 0, 1, no, not 0. Okay, so now we are here with 1, 20 over 41, that's horrible, 6 over 41. You'll see why it's horrible in a minute. And then we'll probably have to stop because it will take another 15 minutes to finish with these numbers. Okay, so 1 times 13 is 13 minus 13 is 0. 20 over 41, I have to multiply it by 13. Let's take it on the side. 20 over 41 multiplied by 13 over 1. So this is I'm sorry?
532.
The top divided by 41?
You want just the whole
Gotta
500?
cross multiply. It's like
Yeah.
2K.
So,
41 times 13 is 532.
but you cannot multiply this.
I know.
No, I was trying to see if I can simplify.
Yeah.
I will never multiply a top with the bottom. So this is 260 divided by 41. So I have to write 260 over 41. Plus, I should say minus 7 now. So one more time. 1 times 13 plus this. Now this times 13 minus 7. And then this times 13 plus 4. So now 260 minus 287 over 41. So this is negative 17 over 41. This is what I have to write up here. Negative 17 over 41. That's what I said. And so on. So you can continue like this, but because of the fractions, you have to be very careful. Okay? We can finish it. I just don't think that this is useful. I would like to finish up the material. We can come back to it. Just remind me at the end of the class if we have time. If not, next time. So finish it later. But is the idea clear? Kathy, is the idea clear? What we're trying to do?
Yeah, it's just repetition.
Yes, it is. It's just repetition. Okay. So going back to our,
There's no way to prove it actually, so because you don't have the original formulas,
the system.
the original system.
Of course you have the original system. Of course you have the original system. Once you have the augmented matrix, you have the original system. X minus 5y plus 2z minus 2w equals 4. 0, so y minus 3z minus w equals 0. 3x plus 2y minus plus 2z minus w equals 6. Once you have the augmented matrix, it's coming from a system.
Okay.
You can always reconstruct.
Yeah, for-
You can always reconstruct the system, of course. Yes. Okay, so here's where we are. We are trying to accomplish tonight 5.4 and 5.5, and hopefully 8.1, we'll see. And that will be the last section and no more new material. So let's look at 5.4. The last two sections should not, 5.4 and 5.5, should not be totally unknown to you. So 5.4. Systems of nonlinear equations. Systems of nonlinear equations in two variables. The two methods are substitution or elimination. Very similar to what we had with 2 by 2. Okay. Of course, they're nonlinear, so obviously they're a little bit more difficult than the previous ones. On page 587, I would like us to choose a problem from 1 through 18. If you don't want to choose, I will. And a problem from 19 through 28. So we can practice solving systems of nonlinear equations in two variables.
17.
17 it is. Very good. In 17, we have x plus y equals 1. And we have x minus 1 squared plus y plus 2 squared equals 10. Looking at the second equation, can anyone tell us what it is?
Circle.
Very good. Awesome. Great. So we're asked to solve the system. So what are we facing here? We're facing a circle in the second equation. And what is the first equation? A line. So how many points do I expect a line to cross? Very good. So that's the idea. Good. Since the variables are not the same, this is x minus 1 squared. How many terms when I square? If I want to square x minus 1, how many terms will I write?
1, 2, 3.
3 terms.
3 terms. We have an agreement signed on the first day of classes. Not 1, not 4. Good. Okay. So since the variables are not the same, I will use substitution. Which variable you want to substitute for? It doesn't matter, because both of them have coefficient 1. It does not matter. Which one?
Might it just be y equals negative x plus 1?
Very good. That's perfect. And then I will have to replace y in the second equation. It's present in only one spot by negative x plus 1. So can anyone dictate the second equation, please?
X minus 1 squared
Yes?
plus negative x plus 1 plus 2.
Very good. Although this does not make it a simple equation, at least it only has one variable. Thank you so much. Indeed. Very good. So x minus 1 squared, how many terms will you give me, please? Don't torture me.
3.
Good. I'm ready. No, it's minus because the minus inside. Yes? Very good. Now this one has negative x plus 3. Okay. Negative x plus 3, everything squared. So then plus. Very good. 2 times the first times the second, minus 6x, plus, very good, minus 10 equals 0. I brought 10 to the other side because this is quadratic and I have to set it equal to 0. Very good.
Negative x plus 3.
I'm sorry?
Negative x plus
Negative x, 1 plus 2 is 3. Is that okay? Good. So now combine like terms. So this is 2x squared. So this is minus 8x. And this is 10. Oops, look at that. 10 minus 10. We always simplify. I will simplify not by x ever, but I can divide both sides by 2 indeed. So this is x squared minus 4x equals 0. What type of equation is this, and how many x values do I expect? It is quadratic. I expect, bless you, 2 solutions. I will have to factor out x. So I have x equals and x equals. Yes? Very good. This is not good enough. It's very good, but not good enough because it's a system and I have to have ordered pairs. So I have to go back to this equation. With x equals 0, how much is y? Very good. With x equals 4, how much is y? So how many solutions again we expect? I don't know if they work. I haven't checked yet. But what do I expect the solutions to be? Awesome. 4, negative 3. With a question mark, I go back to the original problem and plug in 0, 1, 0, 1, 0, 1. Let's check. 0 plus 1 is 1. 0 minus 1, negative 1 squared, 1, very good. 1 plus 2, 3 squared, 9 plus 1, good. So this is a yes. Now I check 4, negative 3, 4, negative 3, 4, negative 3. 4 minus 3, 4 minus 1, 3 squared, 9. Negative 3 plus 2, negative 1, negative 1 squared, 9 plus 1.
10.
Good. So this is a yes as well. As expected, before we even solved the system, you said a line can cross a circle in 2 points maximum, or not at all, or maybe just tangent. But this is what we expected. Maximum 2 points. Very good. Awesome. Let's choose another, please. (19 through 28, please. So we applied the method of substitution. We substituted by solving the first equation for y, and we plugged it in the second equation. Okay, are we ready to choose? Okay, I am going to choose 19. X squared plus y squared equals 13, and x squared minus y squared equals 5. In this particular problem, both variables in both equations are the same. So I could, if I wanted to, use substitution. However, look how easier this is. I added term by term. I used the elimination method. How much is x squared?
9.
Very good, awesome. Let's go back now.
X equals 3.
No. 2 solutions, please. Yes. So let's go back with x squared. So 9 plus y squared equals 13, which means y squared equals?
4.
Very good. And now, yes, I want the 2 solutions for x. Please give me those 2 solutions.
3 negative 3.
Plus or minus 3. Please give me the 2 solutions for y.
Plus and negative.
Very good. And now, give me all possible solutions, all possible combinations. How do we get the 0? There is no 0.
3, 2.
3 comma 2.
Negative 3, negative 2.
3 comma negative 2.
Nine and 4.
Negative 3,
Comma.
2.
Yes.
Negative 3, negative 2.
Negative 3, negative 2. Very good. So when x is positive 3, these are the 2 options for y. When x is negative 3, these are the 2 options for y. It turns out that this system has 4 possible solutions. Okay, you can say, wait a minute, you haven't checked. Let's go back and check. So I'll check directly x squared. 9 plus 4, 13. 9 minus 4, 5. So now please choose any problem you want from 1 through 42. This is how we solve systems of nonlinear equations in 2 variables. Either substitution or elimination. Any problem, anything you like?
38.
38 it is. So let's copy 38. In 38, we have x squared minus y squared minus 4x plus 6y minus 4 equals 0. And then x squared plus y squared minus 4x minus 6y plus 12 equals 0. Okay, so let's look at the 2 equations. They're kind of all over the place, agreed? They have x squared, they have y squared, they have x, they have y, and some free terms. So I am thinking of potentially elimination because there are so many different types. in there, and I can't really solve any of the two equations for anything. I cannot solve this for x or y, or solve this for x or y. So yes, so let's try and add those two and see what happens. So if I add these two equations, what is left? I agree with 2x squared. This will go away. This will go away. Minus 8x, very good, plus 8 equals awesome. And this is awesome. Why? Because now I obtained the quadratic equation, but it only has one variable, which is, that's it. I have to clean it up first. How do I clean it up? Awesome. Divide both sides by 2. And then I have x squared minus 4x plus 4 equals 0. We have an agreement on this for 3 months. And what does this equal to? Right here, right now, in a blink.
0.
No. See what I have to put up?
Minus 2 squared.
Very good. Thank you very much. So there are two solutions, but actually x equals very good. Okay. What do I do with this? Because the problem is not solved. We're almost there, but it's not done. Yes. I have to go back. You dictate. You tell me where you want to go back. It doesn't matter. So let's say we go back to the first one. Please dictate. Indeed. Minus y squared.
Minus 8.
Plus 6y. And minus 4. Still not too difficult, because it's quadratic in y. And it's a great accomplishment because it only has one variable. So that's great. So negative y squared, these two go away. Plus 6y minus 8 equals 0. What did I always say? I refuse to solve a quadratic equation with a negative leading coefficient. It's a good habit to have. So divide both sides by -1 and factor, please. So there are two options for y. And they are?
4 and 2.
Good. But now I want to determine the solution of the system. Can anyone?
2, 0, 4.
We don't have an x equals 0. We did not determine x equals 0.
2, 4.
2, 4. And 2, 2. Very good. I trust that you will go back and check. Final section of chapter 5.